Alrighty guys, so now we are on to interpreting our graphs, okay? So really and truly, we are just going to be talking about the characteristics that we talked about earlier, okay? Alrighty, so the very first thing we want to identify is our domain. And in the previous video, what did I say that our domain is always going to be? It is always going to be all real numbers, okay? We got that. We're doing good. Okay, so then for our range, we need to know what our asymptote is. So a great way to determine that is to look at our graph over here and just follow it with your pen, and then where that arrow is, you see what it's getting really close to, just start making dashes. Okay, and so then this is our asymptote. What is our asymptote? It's 3. Now, is that x equals or y equals? I'm really hoping you said y equals since it is on the y-axis. So already we can say y equals 3 for our asymptote. And then we can talk about our range. And so we know it's going to deal with y. We know we're going to have a 3. So all we have to do is say if y is greater than our asymptote or less than our asymptote. So what is it, less than or greater than? It's greater than, because our entire graph is above our asymptote. Doing okay? Alrighty. So then, am I going to have any x-intercepts? No. And the reason why is because our asymptote is above our x-axis. If our asymptote is a negative number, then yes, we will have an x-intercept. But if it is a positive number or a 0, we will not have one. Okie dokie. So now, let's take a look at our y-intercept. What's our y-intercept? It's 4. Good. Okay. So then, because, you know, it crosses up 4. Right there. There we go. Alrighty, so then, what is my interval of increasing or decreasing? What do you guys think? So, our interval of increasing is going to be from negative infinity to positive infinity. Why? Because it always increases. We have an increasing function. So, I'm going to put all real numbers, because I like all real numbers. Doing okay? So all real numbers, again, is just another way to say from negative infinity to positive infinity, because we are just following our graph, and since it always increases, it is always going to be all real numbers. Alrighty, for our end behavior. So end behavior is a little bit different in that we are basically talking about our domain and our range. So let's talk about it. I'm going to put it down here, over here, because I would like a little bit more space. So when we're talking about end behavior, there are 2 ways that we talk about it. As x approaches infinity and as x approaches negative infinity. Okay? So this will usually be given to you. But as x approaches infinity, right? So as it goes more and more to the right, what happens to our y values? They're going up. So y approaches what? Positive infinity. Good. Okay, so then as x approaches negative infinity, where's my y going? Hopefully you said it's going towards our asymptote, but it will never cross it or touch it. So that's why we say it approaches 3. So when we're talking about end behavior, your x's will always be given to you, so you have to figure out your y's. One of your y's will always be your asymptote. The other one is either going to be positive infinity or negative infinity. So that was our g. Okay? Alrighty. And then finally, here's something that we have not talked about yet. So in our equation, y equals a times b, this is supposed to be an x. Well, there we go, b to the x. Is our b greater than 1 or less than 1? And explain how you know. Okay, so when b is greater than 1, our graph will always be increasing. And what's our graph doing? It's increasing. So b is going to be greater than 1. This is also called a growth. We doing okay? Alrighty. So then, you guys ready to look at the next one? Alrighty. Let's look at the next one. So this time we are actually given our equation of our function. Okay? Alright, so then let's talk about our domain. What's my domain? All real numbers. Always all real numbers. Okay? And then we are going to talk about our range. So before we talk about our range, what do I need? I need my, starts with an A, I need my asymptote. So it's that line that the graph always approaches but never crosses. So what's my asymptote? Y equals 0. Beautiful. So then when we're talking about our range, we write y, and we write 0. And so then is our graph always above 0 or is it below 0? I'm really hoping you guys said above. Okay, good. So now let's talk about our x-intercepts. Do we have any? Nope. Good. Okay, what about our y-intercept? Can you guys see that? So there is actually secretly, not really secret because you can kind of see the dot right here, almost. I promise there's a dot at 10. Okay, so that is our y-intercept. And oh my gosh, if you look at our equation, what is this very first number that we see here? It's a 10. Wow, could it be a coincidence? Nope. So whatever number is in front of our parentheses, that is going to be our y-intercept. Okay. So you guys hopefully will remember our equation y equals a times b to the x. A is our y-intercept. Okay. Alrighty. So now, intervals of increase or decrease. Well, this one is always decreasing. So we're going to underline decrease. And then it's always decreasing from negative infinity to positive infinity. Alright, so these are always going to be increasing and decreasing for all real numbers. So from now on, we're just going to say decreasing or increasing. Sound good? I thought so. Alrighty, for end behavior. So as x approaches negative infinity and as x approaches positive infinity. What is going on as x approaches negative infinity? Where's y going? It's going up. So y approaches what? Ooh, you cannot see that at all, can you? There we go. Y approaches positive infinity. Beautiful. And so then as x approaches positive infinity, what's y approaching? Our asymptote. Good. So y approaches 0. We doing okay? Alrighty. And so then, for our very last question, in our equation, is our b greater than 1 or less than 1? And explain how you know. So what do you think? So if the last one, we said b was greater than 1 because it was always increasing, and this one is always decreasing, b is going to be less than 1 because our graph is decreasing. Okay? Alrighty. Looking good, looking good. So then next, we are going to take a look at reading exponential graphs. I know we're doing a lot today, but we're doing good, okay? Alright, so we have a bank account that starts with $5, and every month the amount of money in the account is doubled. The equation that represents this situation is y equals 5 times 2 to the x. Wow. So the amount you start with is 5. So then that's our A. And then every month the account is doubled, which is 2, because when you double something, that's 2. And so our equation is y equals 5 times 2 to the x. Wow, maybe the 2 is our b. Wow, that's amazing. Okay, so how much money did you start with? Well, what did it say that we started with? We started with $5. And then, where is this amount located on our graph? So if we go to amount of money, which is on our y-axis, it's kind of hard to see on my computer screen, but you guys can look on your actual paper. It says amount of dollars. And if we go to $5, hey, that's our y-intercept. And then, how much money do you have after 2 months? Well, go to 2 months. And that says $20. All right. After how many months do you have $10? So now we have to look at our amount of money, go to $10, and that was 1 month. So then, what does the 5 and the 2 represent in our equation y equals 5 times 2 to the x? Alrighty, so we already said that our $5 was our starting amount, because it even said so. How much money did you start with? And so then 2 is going to be our growth rate. Because this is how much we grow by. Because we started at 5, 5 times 2 gives us 10, 10 times 2 is 20, 20 times 2 is 40. So that's what we multiply by each time to get our next number. Okay? Oops, y values doubled. Alrighty, so that's how we interpret an exponential graph. Now, I said growth rate because our graph was increasing. Okay? So then, in our next one, you might notice that our graph is decreasing. So let's take a look at it. Okay. So scientists began observing a certain breed of owls. At the beginning, there were 20,000 owls in the wild. Every year, the population of owls was halved. The equation that represents this situation is 20,000 times 1/2 to the x. And we're going to use the graph to answer our questions. So then, what was our initial population? In the beginning, 20,000. And then, where's this amount located on our graph? It's located right here, population of owls. And that is called our y-intercept. So then, what was our population of owls after 2 years? So we go to 2, up to our graph, and that's 5,000 owls. And then, after how many years is the population 2,500? So you would go in between 0 and 5,000, and then follow it to our graph, which is about right here. And so that would be 3 years. So then, what does our 2,000 represent? Our 2,000 was our initial population. Of owls. Oops, sorry. And then what does the 1/2 represent? Our 1/2 is our decay rate. So in our previous problem, because we were increasing, that's called growth. When we are decreasing, that's going to be called decay. All right, because our population was halved. Alrighty, so you guys just learned so much about exponential functions. Good job, guys.